do this. Cut it off. And today we're going to be collecting some data, and we're going to use this data and look at this data to kind of figure some things out. So I'm going to start by making this number line. So I'm going to write 0, 1, 2, 3. I'm just going to use this to record my data for. And kids love to collect data from each other. So some of those B decimal cards have them like measuring people's hands, and then they find the average size of children in the classroom. So
mine measured each other's heads, the circumference of their heads.
Nice.
I came up with it.
That's a good one to tie back into Coming of Humans. And is your head, what hominid does your head match?
Oh, nice.
See, culture.
All right, and so you can decide what kind of data you might think might interest your group. Things I will do are often like how many siblings you have. And we talk about what kinds of things are easy to collect data this way, like your favorite color isn't a number. So that's going to be hard to do math things with that data. So that would not necessarily be something that we might want to do. But let's say I was going to find out how many siblings everyone had, which actually that one was kind of an interesting one because it brought up a lot of conversations. So I don't know if those were good or bad, but it just is, and some people were like, I don't know how many siblings I have. And then they would sit there and count them. And I was like, what is this? Anyway.
There's just taking a turn.
There's just things that maybe in your life you may not have, might be surprising. And you're like, okay. Well, we're just gonna, and then so pets is kind of an easy one, but then sometimes somebody says they have like 15 pets, and I'm like, really?
Yeah.
I don't know if I count all my isopods, maybe.
They get creative.
Okay.
Yes.
So anyway, I only went up to 13, so 13 is the max data point that we can have here. So let's just do siblings in this group today. So I'm going to start with myself. I have 4 siblings. I'm going to put this X above the 4. Holly, how many siblings do you have?
8.
8. Okay. Shelly, how many siblings do you have?
I grew up with 2.
Okay.
We'll go there.
And you get to define that however you want, right? This is not, we're not collecting census data here. So, Avram?
6.
6. So many big families.
It's not a good thing in mine.
Before the economy
I think the 8th
just
good.
got out of control.
Shante. How many siblings? 3. Okay.
2.
2. Great. Oh gosh. Glad that's a washable marker. 2. All right. And so 1, 2, 3, 4, 5, 6. I'm going to throw in one more piece of data just for simplicity's sake, and I'm going to say that somebody else has 0 siblings. We have one mystery lonely, not lonely, only child. Maybe they are lonely. We can't even see them, so maybe they are lonely. All right. So this is our set of data, right? And sometimes it's helpful when we are looking at data to look at it in different ways, right? Depends on what we need the data for. So one thing that sometimes we use data for is we might say, well, I need to know the mean number of siblings someone has. Now that doesn't mean how many mean siblings they have, right? Mean is another way of saying average. Have y'all ever heard average? What are some times where maybe you've heard average?
April's average.
Sam is so average.
So average would be like if there are 1, 2, 3, 4, 5, 6 of us, like if we said, okay, everyone has the same number of siblings, how many would that be so that everyone would have the same number of siblings? When we're talking about school grades, your average is if you take all your grades, your high grades and your low grades and all the grades in between, and we put them all together, would be like about what your grade is in total. I always have a hard time defining these.
I know. Your batting average, yeah.
Another one is we might want to know the median. And here's where I bring up driving. Have you ever been driving down the street and there's that concrete part in the middle? Maybe there's grass or trees, or maybe it's just a piece of concrete in the middle. That's called the median. And it's in the middle of the road, and it separates the people going this way and the people going this way. And that's called the median because it's in the middle. So median. And then, let's see, mean, median. Another way we might look at data is the mode. And the mode is the number that happens the most often. So mode, most. And then the last thing that we look at is the range. Like in our upper elementary classroom, the age range of students is typically between 9 and 12. So the range for upper elementary would be between 9 and 12. And so we're going to calculate each of these data points given this information. So the way we collect the mean or figure out the mean is we're going to take all these number of siblings, and I actually brought these cubes because sometimes it's nice to represent it this way. So we have our only child, and they have 0 siblings, and so we won't actually use any cubes for them. But then we have this person, and they have 2 siblings, and this person has 2 siblings, and this person has 3 siblings. Next we have 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, and 8. 1, 2, 3, 4, 5, 6, 7, 8. So we could put all of this together. And let's see, there are 1, 2, 3, 4, 5, 6, 7 data points. So if I wanted to make 7 different stacks, how many would be in each stack? So right now we have 1, 2, 3, 4, 5, 6. I'm going to take some of these off and I'm going to put it right there, right? Because this would be representing all 7 of us. And we want everyone's stack to be the same. That's how we would find the average. So I'm going to take these. I'm going to take one off the top here. We'll add them over here. I'm just going to keep messing with this until we can get it to be about the same for everyone. And wouldn't it be handy if it just worked out perfectly? I don't think it's going to. Because look, these 3 have 3 siblings. And then these 4 would have 4 siblings each. So it's somewhere between 3 and 4 is how many siblings we have if we looked at the average number of siblings. So this is a nice visual way to think of it. But we have a mathematical way we can do it as well. And so we will do that in just a moment. If it worked out evenly, that'd be really cool. But it's kind of a way to just illustrate what the mean really is. And so I'm just going to place these here. Now, who wishes that you could maybe cut one of your siblings in half? Maybe some of us, but that's not something we can do in real life. But sometimes these, when we look at this data, maybe we had whole numbers before, and then we might end up with portions of people, which is kind of weird to think about.
Or see them half the time.
Yes.
That would be great.
Oh, maybe. Okay, not half of them, but you see them half the time. That's better. So right now I'm going to just calculate mathematically how I would calculate the mean. And so we're going to take all of these data points and we're going to add them together. So I have 0. How many does this person have?
2.
2. So 0, 2, we have another 2, 2, 3, 4, 6, and 8. And if we were to add all of these together, this might be a great time for the snake game, right? I like to look for groups of 10. So here we have 6 and 4, that makes 10. We have 3 and 2, that's 5. And 8 and 2 is 10. So if we add those all together, we have 25 siblings total. But now we have to share those siblings between everyone, so everyone has the same amount. So we're going to take that 25 and divide it by the number of data points that we're looking at. And 1, 2, 3, 4, 5, 6, 7, divide it by 7. So here's where we have to start cutting up siblings. So let's go ahead and we're just going to do this division. We're going to skip count by 7. 7, 14, 21, 28. Oh, that's too many. So 3. And how many would be left? 7 times 3 is 21. How many siblings would be left?
4.
4. Let's see. So I'm going to write 4, but 4 sevenths. 3 and 4 sevenths siblings. Again,
There's
let's
our
not
5.
think too much about that. A little bit more than half, right?